Okay, look at one example. Find the slopes of the tangent line to the graph of fx equal to x squared plus 1 at the point 0 and 1 and negative 1 and 2. Okay, so let me show the picture first. So this is a picture of the function fx equal to x squared plus 1. Through this picture, we can actually assume tangent line slope at 0 and 1 looks like 0, and tangent line at negative 1 and 2 is negative slope. But let's check based on definition of tangent line. So what was the definition of tangent line? Yes, m equal to limit delta x move to 0, f delta, x plus delta x minus fx over delta x. Therefore, we need to find this first. So, how to find f delta x plus x plus delta x? Yes, we plug this into here basically, right? Then this is going to be x plus delta x squared plus 1. So if you're using FOIL method, then it will going to be x squared plus 2 delta x plus delta x squared plus 1 basically. So we replace this into this formula, then it's going to be limit delta x move to 0, x squared plus 2 delta x times x plus delta x squared plus 1 minus x squared plus 1 over delta x. So looking one more time here, this is what we have found through here, and this one is original fx here. Good. So I plug those two values into the function. Now we open the parentheses, then limit delta x move to 0, then x squared plus 2 delta x times x plus delta x squared plus 1 minus x squared minus 1 over delta x. So from here you canceled out all these value possibly, then x squared negative x squared plus 1 minus 1. Then it is going to be limit delta x move to 0, 2 delta x times x plus delta x squared over delta x. As you see, this one we can factor by delta x. So limit delta x move to 0, delta x 2x plus delta x over delta x. Therefore, we can cancel delta x here. Then it's going to be limit delta x move to 0, 2x plus delta x. Now plug 0 into delta x. Then it's going to be 2x plus 0, which means 2x. Therefore, tangent line slope m you can define as 2x. Now what do we need? We just need x value here. So go back to the point. It was 0, 1. So 0, 1 and then negative 1, 2, right? So plug those values. Then so m equal to 2, 0 equal to 0 at 0, 1. Therefore, m equal to 0. This case. Now, m equal to 2 times negative 1 equal to negative 2 at the point is negative 1, 2. So m equal to negative 2. So we found two slope, m equal 0, which is at x equal, point 0, 1, and m equal negative 2 at point negative 1 and 2. Good. Let's do one more question. ht equal to t squared plus 4t and point 1, 5. So I would like to ask you to pause this video for a second and try to solve it without watching this video. I have to find the slope and return to this video and check your answer, please. Okay. So this question also, we just make the definition. So this time, for our convenience, I'm gonna notate delta x as h because h look less confused compared to delta x. So I will utilize h instead of delta x. Okay. So tangent line slope m equal to limit h move to 0 f x plus h minus f x over h. So as I told you, I'm gonna use h as delta x. So all delta x value rewritten as h. Good. So first of all, we need to find this value. So f x plus h, which is, so actually it is t plus h, this particular case. So I'm going to say h. So t plus h square plus 4 times t plus h. This is, so using the Fourier formula for this part, then you will get t square plus 2ht plus h square, and this part will be plus 4t plus 4h. Now, because we have this one, just plug this into this position here. So it's going to be limit h move to 0 f x plus h minus fx over h. There will be t squared plus 2ht plus h squared plus 4t plus 4h minus t squared plus 4t over h, which is limit h move to 0 t squared plus 2ht plus h squared plus 4t plus 4h and minus t squared minus 4t over h. So as you see, you can cancel this and this, also this and this. Good. Therefore, this is going to be limit h move to 0 2ht plus h squared plus 4h over h. Now plug 0 into all h. Before we're doing that, we can factor by h. So factor by h, then this is going to be limit h move to 0 h time 2t plus h plus 4 over h. So as you see, we cancel this and this. Now it is going to be limit h move to 0 2t plus h plus 4. Now plug 0 into h, then this become 2t plus 0 plus 4. Therefore m equal to 2t plus 4. Okay, now the given point is 1 comma 5, so plug 1 into t, then m equal to 2 times 1 plus 4, that equal to 2 plus 4 equal to 6. So m equal to 6 at point 1 and 5. Good.